So in the last video, we covered the basics of APIs, the waiter between your app and the server, the four methods, status codes, and JSON. And honestly, that's maybe 20% of what a real API actually looks like. The other 80% is what nobody teaches you: authentication, query parameters, pagination, rate limits, versioning. That's the stuff that separates a tutorial project from a production system. And that's exactly what we are covering today. Let's get into it. Let's start with something that confuses almost every beginner. There are actually two different ways to pass information in a URL. The first one is called a path parameter, and its job is to identify which resource you want. So when you see slash restaurants slash 42, that 42 is part of the address itself. Take it away and you're asking for something completely different. The second one is the query parameter, and instead of identifying anything, it modifies your request. Everything after the question mark. Sort equals rating, page equals 2, limit equals 10, each one chained together with an ampersand. So here's the simple way to remember it. Path parameters say what you want, and query parameters say how you want it. Filtered, sorted, paginated. Watch how each one refines the result without ever changing the resource itself. Now let's talk about headers, the metadata that travels with every single request. There are dozens of them, but honestly, three of them do most of the work. Content type tells the server what format you're sending, and these days, that's almost always application/JSON. Accept is the opposite. It tells the server what format you want back. And then there's the big one, authorization. This header carries the proof of who you actually are. And it's so important that we are going to break it wide open right now. So, how does an API actually know it's really you? There are two common answers. The first is the API key, basically a long random string that the service hands you, and you attach it to every request. It's simple and it works, but think of it like a hotel keycard. Whoever's holding it gets in, no questions asked. And that's exactly why you never ever put API keys in your front end code. The second answer, and this is the one modern apps use, is the JOT, the JSON Web Token. If you look at one, you'll see three parts separated by dots. The first part is the header, which says which algorithm signed it. The middle is the payload. That's your actual data, things like your user ID, your role, and when the token expires. And the last part is the signature. Think of it as a tamper seal. If anyone changes even a single character in that payload, the signature breaks and the server rejects it instantly. And the flow is beautiful. You log in once with your password, the server hands you a token, and from that point on, every request just carries authorization, bearer, and the token. Your password never travels again. When the token expires, you either log in again or use a refresh token. And that right there is modern API authentication. Okay, here's a classic interview question. What's the difference between put and patch? It trips people up all the time, but it's actually simple. Put replaces the entire resource. You send the complete object and whatever was there before gets overwritten. Patch, on the other hand, updates only the fields you actually send. So if you're just changing a phone number, patch sends that one field. With put, you'd have to send the whole profile all over again. And while we are here, there's one more word you should know: idempotent. It sounds fancy, but it just means calling something once or calling it 10 times gives you the exact same result. Get, put, and delete are all idempotent. But post is not. Call post/orders 10 times and congratulations, you've just placed 10 orders. Now imagine an API with a million users in the database. If get/users tried to return all of them at once, it would crash your app and hammer the server at the same time. So instead, APIs paginate. You ask for page 2 with a limit of 20, and the server sends back just those 20 records, along with some metadata: the total count, the current page, and whether there's a next one. Your app then loads page after page as the user scrolls. And here's the fun part: that infinite scroll you use every day on Instagram, that's just pagination in disguise. Servers also protect themselves, and they do it with rate limiting. Most APIs give you a budget, something like 100 requests per minute, and every response quietly tells you where you stand through headers like X rate limit remaining. But cross that limit and you'll meet status code 429. Too many requests, along with a retry after header telling you exactly how long to wait. And here's the difference between production apps and amateur ones. Production apps handle this gracefully. They slow down, they wait, they retry with back off. Amateur apps, they just crash. Here's a problem every API eventually faces. They evolve, but the old apps out there still depend on the old behavior. Change things carelessly, and every single app built on your API breaks overnight. The answer is versioning. And that's exactly why real world URLs look like /v1 slash restaurants. When you need breaking changes, you don't touch v1 at all. You launch v2 right alongside it. Old apps keep running on version 1, new apps move to version 2, and nothing breaks for anyone. Go look at any big API out there: Stripe, Razorpay, Twitter, version numbers everywhere. And finally, errors. Because a good API never just shrugs and says something went wrong, it returns the right status code plus a properly structured error body, a machine readable error code, a human readable message, and details that point to the exact field that failed. That way, your app can read the error and show the user precisely what to fix. Here's the truth: professionals design their errors just as carefully as their successes. That's the real mark of a well built API. So now you know what production APIs are really made of: authentication, parameters, pagination, rate limits, versioning, and proper error handling. That's the stuff working developers deal with every single day. And now you speak the language too. If this cleared things up for you, hit like and subscribe for more explainers just like this one. Thanks for watching. I'll see you in the next one.